Hello guys, welcome to this session, and in this session we are going to talk about ASCII code. This is just it's something so interesting. Basically this session I could say is an extension of data types because I'm going to explaining characters but in more depth. Okay, let's get right to the session. First, let's just declare a character data type and give it a variable. Let's say we're going to call it letter. And then we are going to give this letter a value. Let's say we're going to give it a letter of H, close semicolon. As you all know, if we try to display letter, it's going to show H, just like we do with strings. But there is something very interesting with the character data type, is that instead of mapping into your value or your character that you want it to display, it goes and checks something that is called an ASCII code, and it compares that ASCII code with the letter that you inputted, and then it displays your letter. It doesn't map into your letter. It checks for the ASCII code. Let's say for example, if I add +1 in front of letter and I'm going to run this, the output is a number. Wow. This number is an example of an ASCII code. Okay, now let's take a look at a few ASCII codes and their characters. Here to your left, these are the characters, and to the right is the ASCII code for each character. Each and every single letter or keystroke in your keyboard has its own unique ASCII code. This includes numbers, capital letters, small letters, and even emojis. Like each and every character in your keyboard has its own unique ASCII code. So now let's just declare a variable code letter of data type character, and inside this data type we're going to do something different now. Instead of storing a character, we are going to store an integer number, which is 65. And let's try running this and see what the output will be. As you can see, we get the following value, which is A. That's because something called implicit type conversion has occurred. Now, let's discuss what implicit type conversions are and what they do. Here's an example of a structure of what you just saw on the screen. As you saw, we first declared a character data type and a variable, and we named it letter. And inside this letter, instead of storing a single character, we stored an integer. Here's what happened. Now, I want you to imagine value as a person who's traveling from one place to another. And the left-hand side of the equal sign is the place where he's coming from, or his place of origin. And the right-hand side of the equal sign is the place where he's going. So the left-hand side where there's value is the place where he's coming from, and the right-hand side where there's data type or letter is the place where he's trying to get to. So, and I want you to imagine the equal sign as a border, and inside this border, they have a machine that makes you forget your native or your origin language or the language that you speak, and it makes you know the language where the people in your destination speak, right? And okay, let's say this person is traveling, he comes from his place of origin and he's going to his place of destination. As soon as he reaches the border, which is the equal sign, they're going to run the scan on his brain, and he's going to forget his original language, native language, or the language that he knew before. And then they're going to run another scan on his brain, which will make him know the language that the people at his destination or at the place where he's going to speak. Now, I want you to think of the languages in this world as data types. So this person, before he crossed the border, he used to speak the language integer. Now that he crossed the border, he's on the other side of the border. Now he speaks character. So this is what implicit type conversion is. Now imagine implicit type conversion as the scanner that does that makes the person to forget his native language and know the language that the people in his destination speak. If you don't understand, don't worry, we're still gonna explain this in more depth. There's also an alternative conversion. This is called an explicit type conversion. Let's look at it right now. Here, let's just declare an integer and let's give it a variable of number. And this number, we're going to convert this number into a character explicitly, which means externally. And we're going to intentionally convert this number into a character by choice. So it's not something that the computer does by default. It's our choice to do this. So let's run this and see what happens. As you can see, we get the same results. We get A. And this is an example of an explicit type conversion. Now, let us take a look at another example. Now, instead of converting an integer into a number, let's just convert a number into a number. For example, a decimal number or a number with a floating point into an integer number. So first, we're just going to declare float data type and give it a variable called number. And inside this number, we're just going to store a random decimal number. Let's say 8 point, just random numbers after the comma. And we are going to explicitly convert number into an integer. So we're converting a decimal number into an integer. And we're just going to use the same explicit type conversion technique, which is you write a data type and you open close bracket, inside you put your variable. And we're just going to run this. As you see, it throws away each and every number after the comma. That's because, remember, integers cannot be decimals, and the number 8 got converted into an integer explicitly. Okay, now let's get right back into ASCII codes. Now let's try something a little different. Instead of just displaying characters and their ASCII codes, now let's try using mathematical operators to manipulate the implicit type conversion technique. As you see on the screen, we declared a character data type and we gave it a variable letter, and we're going to take a letter and add 1 to it. And let's run this and see what the output will be. As you can see, it displays B. Isn't it cool? Now, let's just take a look at what happened behind the scenes. Remember, the ASCII code for A is 65 and the ASCII code for B is 66. Here's what happened. Each time you use a mathematical operator, it could be plus, minus, divide by, and times. Each and every character right next to that operator gets implicitly converted into its ASCII code, and it's going to perform mathematical operation, and when it's done, it's going to store the value inside the variable. Remember our language bridge model? Well, the same principle or concept has occurred here. That's why you see B on the screen. Notice how implicit type conversion has occurred 2 times here. First, A got converted into its ASCII code, which is 65. Then 65 is going to be added to 1, which gives you 66. And then after that, remember the language bridge model, as soon as it crosses the equal sign, implicit type conversion is going to happen, and 66 will get converted into a character. And the ASCII code for 66 is B, as you see on the screen. Okay, now let's just try something different. Instead of adding 1, let's just add 2 to A and run this. Obviously, it will display C because C is 2 steps away from A, which means 65 plus 2 will give you 67, and the character for 67 is C. So the same goes for each and every other character. So you can use this technique to manipulate or change words or place them in a random or strange way. Now let's just change this a little bit. Instead of adding a number with a character, let's add a character with a character and run this and see what the output will be. Wow, we get a strange letter. Again, let's go behind the scenes and see what happened. Remember I said when you use a mathematical operator, it could be divide by, times, plus, or minus to add a character with a number. Implicit type conversion will occur. That goes the same when you add a character with a character. So each letter of A here will get implicitly converted into its ASCII code, which is 65. And 65 plus 65 will give you 130. And then it's going to cross the equal sign and try to store 130 into the variable letter, which is a character. And the ASCII code for that strange letter is 130. That's why you saw that strange letter. So I hope you understood how to use implicit and explicit type conversions to display or manipulate different characters and their ASCII codes. Thank you for joining me. See you in the next lesson.